Welcome back, polar bears and polar cubs. Let's go ahead and let's talk some molecular shapes as well as some electron group arrangements. So, um, all of this, all this whole entire um, set of notes that we're going to talk about when it comes to this, columns 5 through 8 plus 11 are dependent. Okay, they're dependent on column 4. Okay, so really, column 4 is the most important column. You need to make sure that you have your drawings down in order to really move on within this worksheet. So, this is going to be number 5. Number 6 is B. So for 5, we're talking about bonded atoms to the central atom. So for example, one of the ones that we've had in the past, if we want to go back and just see, we had SeO3. Okay, so that was allowed to have 24. So you had 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So when we're talking about bonded to the central atom, there are 3 oxygens bonded. That double bond, it's still the same atom bonded there. It's just bonded twice. Lone pairs, you're looking around Se. There are no dots around Se, so there would be a 0. That's how we're going to count them. Now, when it comes to diatomics, so if you see just one of our diatomics, there are 7, don't forget about those, or an ionic compound, they don't have shapes. So what you'll actually do is for columns 5 through 11, you'll just put a nice little dash in those. A nice reminder, column 5 is going to be the bonded atoms. You're going to have anywhere from 2 to 4 bonded atoms in there. Lone pairs, you're going to have anywhere from 0 to 2. Okay. Otherwise, they're going to be dashes. Remember, the arrangement of the rest of atoms around the central, if there's particles that are covalently bonded, they're dashes for only when they have 2. Okay, so like for example, if it's HCl, those would be dashes because they don't have a central atom. There is no central atom. They would also then have some dashes in the worksheet further down. The big reminder is that 8 electrons for everybody, except for our exceptions. Keep in mind, beryllium is the big exception because it is a metal that bonds like a nonmetal. It is a metal that bonds covalently. So let's talk about the bonded atoms. Here, this is ionic, so this would have a dash and a dash. Carbon here would have 4 bonded. It would have 0 lone pairs then. SeO3 we had just done. It is 3 and 0. And then PO2 minus. Let's show this one again. So you have P. P is 5 valence electrons, 6 with the negative. That gives us a grand total of 18. And if we put 2 more here, let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18. Go ahead and put that in a negative bracket. So you'll see that there are 2 bonded and there is 1 lone pair. This being our lone pair. And that's how you do columns 5 and 6. Now, 6, having 5 and 6 filled in, 7, 8, and 11, those are dependent on 5 and 6. So there are only a certain number of different groups when it comes to 5 and 6. So you can have 4 and 0. You can have 3 and 1. You can also have 2 and 2. You can have 3, 0, 2, 1, and 2. Oops. And 2, 0. So these are our different combinations. And then we're going to fill in our chart. In your notes, you should have a nice chart that you can fill in as you go through these notes. So the high density shape, these take into consideration the bonded atoms as well as the lone pairs. So anything that 5 and 6, this being 5, this being 6, if you add those up and it equals 4, it is going to be tetrahedral. Okay, so this is tetrahedral as well. And this would be tetrahedral as well. Now, if you have 0 lone pairs, that means that 7 and 8 would be equal. Therefore, this would be tetrahedral. And the bond angle numerically is going to be 109.5 degrees. Now, if there's one lone pair and it's tetrahedral, it becomes trigonal pyramidal. I'll get back to you on that spelling. So our angle there, we put a less than sign for every lone pair that is there on the central. The next one, super easy. There's 2 lone pairs. It becomes bent dash 2. This is less than 109.5. And the reason that we do the double less than signs is so you guys only have so many numerical bond angles to remember. Moving down, we're into our next set of combinations. These ones equal 3. They become trigonal planar. Trigonal planar, if it adds up to 3. If there are no lone pairs, it would also be equal. So it would be trigonal planar. Now, if you had something that was in a plane and had 3 things attached to it, the angle between those 3 things, think of a circle, is 120. So then, if we have a lone pair here, this becomes less than 120. And I'm wondering what that shape could be. Well, that shape is bent dash 1. Getting the 1 from the number of lone pairs, just like bent 2, got its 2 from the lone pairs. And finally, if you have 2 things attached to you and they are as far apart as possible, it becomes 180 degrees apart, and that makes a linear shaped molecule. There is your chart. It is a chart that I would say you might want to memorize, make some flashcards, something along those lines, so that you can fully understand which ones go with which. So, what really does it show? Well, the big thing that we want to know is VSEPR theory. So, VSEPR theory is the valence shell electron pair repulsion theory. So, what it tells you is that, when we have like water, for example, and it has these two lone pairs. Well, think about it. Those lone pairs are four negatively charged particles. Negative charges don't like to come; they like to repel each other. So all it's saying is that those forces are going to repel each other, and they're going to force those bonds closer and closer and closer together. So what I'm going to do right now is I'm going to go ahead and take you to a PhET. Okay, we're going to go to a PhET, and I'm going to show you some of the actual molecules. So, in theory, okay, if I were to have the four bonded together, you'll see that it is tetrahedral, and then it is also tetrahedral. If I get rid of one and add a lone pair, that is where we get trigonal pyramidal. And I will go back and I will fix that right now. Okay. Okay. And then back to this. So with this, okay, you have your trigonal planar here. So there's our trigonal pyramidal. So if you look at it, if we pull this up, you can see where you have that kind of pyramid, but you still have a triangle. If I get rid of one of the bonded and put another, you can see that how it's bent. We like to put that bent -2 as more of an indicator. So if I get rid of one, you have bent /1, trigonal planar. Get rid of one, the lone pairs, you'll see that you have all three in the same plane, giving us trigonal planar. And then if you get rid of one, you have a nice linear molecule. And you guys are more than welcome to look at those. One of the ways that I like to show you that less than 109.5 is right here with water. It would be a bent -2. And you can see that its bond angle is 104.5. That's way less than 109.5. And if I go to ammonia, this is a trigonal pyramidal. You can see that it's 107.8. So instead of having 109.5, 107.8, and 104.5, we just use those less than and double less than signs. All right, and right there is columns 5, 6, 7, 8, and 11. All right, let me know if you have any questions. Other than that, I'll see you guys when I do.